So I'll start off with the first couple of slides. Graham Cubit's my name, and I'm the Director of Projects and Development with Indwell. We are a charity based in Hamilton, Ontario, but serving communities across Southern Ontario, providing affordable housing and supportive housing to people who, many of whom live with a mental health issue or other kinds of disabilities. But all of our tenants have a low and fixed income. And so the affordability has always been key to us in developing our projects. I'll briefly highlight sort of the arc of our journey, and then we'll talk specifically about one of our projects, McQuestion Lofts. But 10 years ago, we opened our first sort of multi-residential larger scale project. Before that, we just sort of owned, multi-residential buildings that were built in the 60s or small group homes. But we turned this bar into a new 3-story building and had 46 apartments, shooting for about 40% better than code. That was our first experience at trying to do something related to energy efficiency, and it was actually quite successful. The next attempt we made was to convert an old industrial building, a factory that had been vacant for about 20 years, into 54 apartments. Since then, we've added another 26 units, so it's a total of 80 tenants living there. And in that building, we tried geothermal off of an open loop ground source heat pump running off of an aquifer under that city. So that's an interesting experiment, and it's actually worked out very well. But again, trying to push ourselves towards energy efficiency using the best knowledge that we had at the time. 2015 was when that was. 2016, we opened a new construction building, our first time building a new multi-residential building, and told our design team, these are what we're shooting for. Everybody was like, yep, all on board. Our architects paid attention, our structural engineers paid attention. Our mechanical engineer said yes to everything we asked for, and then said, well, we do it all the time like this on Toronto condos. And we ended up with a building that didn't perform nearly like we'd hoped or thought we'd designed. So that was also a learning curve along the way. In the next photo there, we realized, like, okay, if we're going to make a big change, we actually need to rethink from the ground up how we're doing energy efficiency. And we, by that point, had enough experience working with our design team, excluding that mechanical contractor I was talking about, to say, we like working with all of you, from the contractor to the design team to our in-house group. If we step back and want to relearn or want to shoot for these very low energy targets to the goal of becoming GHG free, what are we going to need to do? And can we set aside everything that we know, or at least this, well, we've always done it that way attitude, and focus on relearning from the ground up? And so we did that. Our team joined, we sat on the same side of the table in a sense and said, okay, we're going to learn forward, and did so, starting with this project, Parkdale Landing, which was a retrofit of an old nightclub, bar, rooming house complex, using the Enerfit standard from PHI. Turned into 57.
You can see what it looked like on the bottom right.
Yeah, it was a really complete ugly dive. Yeah, when the demo contractor says it's in their top 10 worst projects that they've seen, you know that you've got a real piece of work on your hands. But in the end, it's 57 studio apartments, providing an enhanced level of support for tenants who've been homeless, combined with some ground floor commercial and even a community or a neighborhood food hub and culinary kitchen, a culinary academy in a commercial kitchen on the ground floor there. So a lot of learning from that project along the way, for sure. That's the first part of a site called Parkdale Landing that McQuestion Lofts is on. But Emma, I'm not sure which slide I'm supposed to finish on, if it's this one or...
Oh, keep going.
Keep going, okay. As part of that journey, though, committing to Passive House, we said that we were designing multiple projects at the same time and needed to sort of learn simultaneously, or like at least in very short succession, with quite a bit of overlap. This project was it was our third project designed, but our second project constructed. It was 34 one-bedroom apartments with quite a bit of amenity space for tenants, but we used a prefabricated system called Build Smart as part of that project, and really trying to again push ourselves to learn on the fly and incorporate everything we could from that one into our next project, which was designed. Oh, there's another photo of there. Actually, that's interesting, that photo there. You can see the solar panel array there. The building was designed to be 69% more energy efficient than code, and actually generate 67% of its no, 69% better than code, 67% reduction in GHG emissions, and actually be electricity positive based on the consumption projections for that building. So that was a lot of learning in one site, and you can see there was a conversion or a rebuilding of a building where there had been an old group home. So we were also dealing with a very constricted site.
In the end, this building just got certified with PHI for low energy building, but I bet we could have gotten better than that because they didn't end up plugging in all the refrigerators in the kitchen.
That's right.
But c'est la vie.
And then this project here was our third project to a Passive House standard, Passive House PHI, Passive House Institute, and just got certificate. Well, it's just pending certification. We're just in the final throes of that. It's been open for a year now, and has 45 apartments. But also on this building, half of the square footage, about 30,000 square feet of church space, with a large gathering hall, community kitchens, offices, and a 500-seat auditorium gymnasium for the church facilities. So it was a large-scale project. It was our second project through design, but the third project finished. And so many of the things that we were able to learn in the first two projects were incorporated into this one as we moved through construction. And then that project opened in 2020, and then in 2021, we are thankful to open McQueston Lofts, which is the project we're going to talk about tonight. And it's in the background there. You can see part of it. And that one was to the PHI or FIAS standard, and got certified 3 months after opening. Last February, we got certification for that project. So I'll pass it over to Emma now. Yeah.
Okay. So I'm going to share some of the construction photos that we've put together so you can see the progression of this project as we went through the different phases. And then Greg's going to talk more about the technical parts of, he was our Passive House consultant for this and really helped to guide the team beyond what we had learned in our first 3 projects to really like tighten up what we were doing and be able to create a building that I think would be very replicable. So you can see the one thing that we changed in our detailing is how we were doing foundations. And in this one, we have regular footings. But in the earlier projects, we were wrapping insulation all the way around the footings and underneath, which is just a lot more work. So on this project, we modeled it so that we could just go to the top of the footing. Just a few things that were small differences that made it easier for contractors. And we've kind of used that going forward. But each time we do model it to make sure that we're within where we want to be. This project was pretty much all wood construction, except for a few shafts and shear walls. So you can see that going up here. Sorry, it's slow. One interesting thing we did was we've started using zip boards. I know it's very common in the States, but in Canada, not as much. But we had learned about them by using the Build Smart system on the project before this, where it was all prefab wall panels all the way to the Passive House windows, and then brought onto site. And we realized that we really liked having that weather barrier integrated into the wall system. And we also really liked on that project how we had 2x6 studs with the mineral wool bats, and then the air barrier was the zip board sheathing, and then outside of that we had several inches of insulation. It's kind of changed on different projects depending on other factors in the design, but I think on this project we had 3 inches on the outside, and now we've moved to using 4 inches more often. Is that right, Greg? Okay.
Yeah, that's right. Yeah. I like this
on
photo.
The outside of the sheathing, but when we have stairwells, then we'll have 6 inches on the outside.
Yeah.
Because of the connectivity.
I like this photo, Emma, because it's like an energy modeler's dream. There's no windows. So I got my
Yeah.
way on this project.
We were worried when people were driving by and they think like, what is this? That's housing. So few more pictures of things coming together. So you can see we started with more complicated details around windows on our earlier projects, and we had fiberglass angles that were supporting windows that were sticking outside of the structure, things like that. But then began using plywood bucks. And on in these projects, you can see where we used what's it called? Viscon to do an air barrier seal around it. Actually, on more recent projects, we've been using a membrane instead to do the same thing. Just trying to see what can be kind of easier and more cost effective for our contractors. Another thing, the picture on the bottom right shows how we have, I think it's 1 inch of interior insulation that goes over the jambs of the window. And while we actually on our first projects had both exterior and interior over insulation, and by doing therm models on those projects realized that we got more bang for our buck by doing it on the inside, and it was also a lot easier for them to install. So we've and it also didn't conflict with different types of windows that we would work with that would have weeping holes and stuff like that. So we've moved to having interior insulation and making sure that the hinges of whatever window we end up using will work with that. So you can actually see the middle picture. This is a Veta window, which is out of Poland. And we've been really happy with these beautiful wood windows, but because of the way the hinges work, we ended up hinging in the middle so that you don't have any problems when you're working on the jambs. Also on earlier projects, we were doing the air sealing from the outside of the window and kind of going around the bucks, and realized that was a lot of work. So now we've been sealing from the inside. Here you can see punched windows happening, and how they're overhanging into partially into the layer of the exterior insulation. We also have balconies in this project, which are common balconies for each floor for the tenants, and it has self-supported structure. More progress moving up. This is the common room on the top floor. It has some very nice views, and next one is, so this is how we were doing the exterior insulation, and we've actually replicated this wall system on the next, I don't know, half dozen projects that we've been working on. And yeah, 10 projects. Because we know that we found the type of fasteners that work well with the furring, found the kind of most cost-effective but type of strapping that we're comfortable is going to be able to be partially outdoors but still be able to withstand the weather. What else do I say about this? Sometimes we've had to do double strapping when we have like fiber cement panel, but on this project we were using a very cost-effective cladding, which was corrugated metal. Looks like shipping containers, because we were trying to replicate some of the industrial sector that this project is right next to in gritty industrial North End Hamilton. So anyway, so we could just have the horizontal fasteners, and then the drainage was behind. We ended up using Comfort Board 110 on our projects going forward because it's got extra rigidity, so that it'll be easier for the siding to go on and kind of hold its form. So here's the project coming together. You can start to see the shipping container look a bit. Greg, maybe you can speak to the mechanical systems, not my forte as much.
Sure, yeah, I am happy to do that. So the ventilation system is a central system, and there's 2 Swagon ERVs that provide ventilation to all the rooms in the building. And they do have VRF post heating and cooling on them as well, to temper that air before they get supplied to each space. And then the main heating and cooling system for the building is a VRF system, and I'll talk a bit about that later on. But in the rooms themselves, they're small rooms. They just have a ductless mini split. And in different spaces like the common area Emma had mentioned, or the library, there's ducted fan coils. And this project, it was a number of years ago when it was designed that we were still in the era when we were using natural gas hot water heating. And that is something that Indwell has really made it clear they do not want to do moving forward. So we are trying new things, but this was one of the last natural gas central water heating systems that you guys did.
Great, thanks. So just a few more pictures of the completed project, and then Greg will be able to share more of the technical aspects to the project. There's actually an Indigenous partner that Indwell had for this project that does placement of some of the tenants. So we use that, the design ethics, I guess, of the local Indigenous community and some of the landscaping that we created. Here's a living room, typical living room, and a typical kitchen coming up. Sorry, I don't know why it's so slow. Oh, shoot. Okay, kitchen. Here's the ground floor library. It's just a little branch library. And their first pest house library in Canada, I think. It's a bit of about the rooftop solar that we have on this project. And yeah, we're so happy to be able to win this amazing award for the project, and hope it's something that can be really replicated in other communities. So going forward, we have a ton of projects that are currently under construction, and just as many that are in various stages of design right now for Indwell specifically. And we've also, my firm has been able to grow to design for lots of other, especially nonprofit housing organizations, to passive house too, which is amazing. So a few of the projects here, for those that are familiar with Ontario, it's all across Southern Ontario. And we actually have 4 projects that are going to be getting occupancy this spring. So we'll be able to continue to share the passive house love with those tenants, and monitor them and study them, and hopefully learn from them so we can keep making these projects that much better. And so we just had 5 takeaways, kind of high-level takeaways that Graham and I have shared in other talks. One would be willing and trusting partnerships are key. You can see that in the team that we were doing the initial passive house training with. We're pretty much the same team now. We've kind of been learning and growing together for most of these Indwell projects. However, we want to also work with others so that we can kind of teach them too, and have this movement be able to grow. The learning curve can be a big one to overcome in the first project, but it gets easier over time. It's a great tool to meet low carbon targets. We've certainly learned that as we've gotten off gas on the last several projects. Also a great tool, at least in Canada, for the type of funding that Indwell's been able to get from the federal government for these projects. Passive house can be cost competitive. On our slides, we were sharing the cost per square foot, and while it's very regional and there's been so much escalation over the last few years, it's really hard to be able to compare costs when we do with other market contractors that are willing to share their numbers. We know that it's pretty darn close. We actually had an NRCan study done that showed about a 5% increase, 4 to 5% increase. And we believe that to be true. And monitoring is key. So Greg's going to share a bit more about how that's been going too.
Great. Thanks, Emma. So I just thought I would kind of close up the presentation and maybe add a few interesting little ideas we could talk about in the QA, but by adding 5 kind of lessons learned that I've had going along with the journey with Emma and Graham. Some of these are going to be pretty obvious, but there's a lot behind them. And so I thought I'd just mention them. One of the really cool things about working with this group is that we've had this amazing set of projects all sequentially, and it rarely ever happens in the life of a passive house consultant. You're here and you're there, and you do all this work on one project, and then you got to start over from scratch on the next. And with this group, we don't have that same kind of challenge. So one of the lessons that I've learned is an obvious one, and that gets talked a lot about on Accelerator, but it's the acknowledgement that further work is required to make sure that we align PHPP with WWOOFy passive. This has really come to light with Indwell. I really hope to do a presentation on this in the future, but Indwell has done an amazing thing in that they've let us do energy monitoring on 10 different multifamily projects, and not just one meter. We have meters for almost all the end uses that match up to the energy model. Everything from clothes dryers to washers to their commercial kitchens. And we're slowly going through, the data's coming in, we're seeing it, and we're tracking it versus the PHPP and WWOOFy models. And so I think there's a lot that Indwell is going to be able to offer the people on this call and others in the passive house industry to help develop things. The second thing that I feel like is really important out of this learning experience is that a good contractor is critical. And obviously, that is a pretty clear statement. I've worked with some really poor contractors that don't care, but Indwell has somehow found some really great contractors. And I think part of it's because they're going with something along the lines of a construction management, where they are interested in the project from the beginning of it, like very early. And they're with us the whole way through. And anytime we have a technical challenge, they're bringing ideas. The next one is ERVs. Just a question there. I'm starting to question whether central ERVs are a good approach for multifamily. So we can talk more about that a bit later. There's a couple interesting things that we're learning in Indwell projects. The other big lesson learned that we had very, very early was that we kind of gave into the temptation of going to very basic variable refrigerant flow systems for heating and cooling. The type that don't give you simultaneous heating and cooling and don't let you move heat around the building. That's something that I'd like to kind of talk about. We've learned our lesson. We're going to be going with simultaneous heating and cooling ones in the future with heat reclaim. Next slide, Emma.
Trying.
Yeah. And this is the last one I just wanted to leave you with, and I got a couple interesting slides right after this. So the biggest thing is that I get it's interesting to see how each team works. And one common thing I see as a passive house consultant a lot using PHI and both and FIAS is that each project seems to always want to start from scratch again and throw out all the ideas from other people and from previous projects and come up with new great details. There are some exceptions, and this has been one of them, where the team basically just learned from their first project Graham started with, and we just went all through each project and we learned and we looked at the details over and over again. We asked the contractors what we needed to do better. We fixed them. We tried them on the next project. We tweaked it. And ultimately, it's so much better now. There's less education required for the designers, but a lot on the site as well. People just know what to do now. And that just results in material and construction optimization. So 2 good examples of that are the wall systems, where we started our passive house journey with Build Smart at first, and that wall system shows all sorts of potential. And we did build the one project with it. The second one, which kind of started at the same time, used the photo that you see there, which was all exterior insulation. The product there is a green girt with 6 inches of cavity rock, Rockwell cavity rock. But we ended up, through pricing and working with the contractors and finding out what they liked and didn't like about those projects, we ended up with this last system that Emma described from McQuest and Lofts. And that one, we've just replicated it for 9 projects. We've thickened the insulation. We've found ways to optimize it, but it's a very cost competitive wall system, and we all know how to make it airtight. And the next slide shows that. I thought this slide was really cool. I took all the air tightness tests that have been done for the Indwell projects, and what you see here is that their first test, which they do when the air barrier is complete, are the blue bars. The second test is after mechanical systems and most of the electricals in. There might have been a few exterior doors missing at the time, and the gray bars where they ended up in the end. And this graph is organized sequentially, so their first project's at the top, and they're next at the bottom. And the red dotted line is the passive house target. So you can just see how great these contractors are doing. Their first tests are always below 0.2 air changes per hour, and they always end up less than the targets. And they're getting better and better each time, and that's because they know what to do on each project. And we've just gained a level of comfort doing that. And the next slide is the same, just articulated as slightly different to the FIA targets. Interestingly enough, some of the projects wouldn't meet the FIAS targets, but they did meet PHI. But anyway, I thought that was a really unique thing that just showed how we all built as a team and where we are now.
And Greg, that first one there is a retrofit actually. So that one,
Yeah.
it was a complicated building.
Yeah.